Okay guys, so we have a question that gives us the second derivative and the first derivative. Okay, so we have y prime and y double prime. Furthermore, we have a point. This is not a function. We just know on the position function, which is y, otherwise f of x, there exists a point which is 0, 0, where the x value is 0 and the y value is 0. This is my x value. This is my output y value. All right. So what we're trying to do is we're trying to find the particular solution that satisfies the differential equation. This initial condition is the point that they give us so that we can solve what is the f of x, original f of x equation, okay? Think of this initial condition that they gave us the same as what you did when you had something that looked like this in Algebra 1. We need to be given a point. Let's say we were still given 0, 0 for this particular example. We plug that 0 in, we plug that 0 in, so therefore b would be 0. So this could just result with, y is equal to 3x. So when you solve for the y-intercept way back in Algebra 1, like that b value, you needed an initial value. You need an initial point that needs to be given to you so that you can solve for b. Since b is 0 in this case, that would be your particular solution. We call this a general solution, okay? A general solution, and when we use a point, it becomes more particular. It becomes more exact, more accurate, and this right here would be a particular solution. So that's just an example of how I compared way back when with Algebra 1. Let's see what we're doing now with calculus. If our goal is to go backwards 2 levels to get back to our original f of x with all the known, in this case, b values, which we now use in calculus as c, we need to integrate this twice using that plus c 2 times. All right? So I'm going to integrate this f double prime of x. And we know the second derivative when I integrate it will look something like this. Okay? So this is my setup for the indefinite integral. And the reverse power rule says I'm going to do what to this negative 3/2? Anyone?
Add 1.
I'm going to add 1, right? And when I add 1, what's the fraction that I'm adding? 2 over 2. A form of 1 is 2 over 2. And we chose 2 over 2 because of the fact that we need a common denominator. So this negative 3/2 plus this form of 1, anyone is going to give us negative 1/2. So our antiderivative is x to the negative 1/2. And we've talked about this before. You can either divide by that new power, or what I would hope that you would do is just multiply by the reciprocal. Okay? What am I missing right now with the antiderivative? Plus c. Now this right here represents f prime of x. We took this integrand of f double prime. We integrated. Notice how the dx and the summation sign go away after this step. And we're left with its integral of f prime right here. Now if I were to write over here off to the side, f prime of x is equal to this negative 2x to the negative 1/2 plus c. You don't have to rewrite it as far as throughout the problem. You don't have to rewrite this with positive powers and move that downstairs because you're going to end up moving it back upstairs anyway. So you could just interpret this as negative 2 over this x, the square root of x in the denominator. Okay, just off to the side you can interpret it like that. Okay, now we have this initial point here, that's on the position function, that I'm going to plug in this input value of x everywhere where I see an x. Okay?
Wait, you're using the position function, you should use the loss function to solve the loss. You're plugging the position into the loss function.
Correct. It's still going to have the at moment nonetheless. Oh, I see what you're saying. Thank you. Thank you for that. So with this, if I'm using this, thank you very much, Nathan, not the position function, but using the point that they gave us as far as f prime of 4 is equal to 3, we know that the x value here, is 4, and we're going to plug that in here. And the y value of the derivative is 3. So So all of this is going to equal 3 is equal to negative 2, and then it's 4 to the negative 1/2, and then it's plus c. So we know this 4 to the negative 1/2 is the same that looks like this. So it's really the square root of 4 down in the denominator, which with this would then equal what? Negative 1. Because it's this negative 2 over the square root of 4. So you get a negative 1 plus c is equal to 3. Anyone, what's c? 4. So now my general solution becomes more particular and more exact. And we're going to write that over here as, let me make some room. Now that we know our c value, we're going to say f prime of x is equal to this negative 2, x to the negative 1/2 plus 4. Okay? From solving that c value. Now, we can, if you want, write it like this. But nonetheless, we're going to have to integrate one more time. We have to get all the way to the position function in order to get the solution to this differential equation. Because again, the solution to differential equations is going all the way back to f of x. So we want f of x is equal to, just like the problem is asking. Alright, so we're going to integrate one more time. So if I integrate this, basically both sides, this f prime of x is going to become f of x, and thus we're just going to end up integrating this and doing plus c again. Alright, so let me show you the work over here for that piece. We have the integral of negative 2x to the negative 1/2 plus 4. It is in respect to x. And you can rewrite, some of you can see it already. If you struggle with this, I would constant multiple roll this negative 2 out. And I would divide this up into two separate integrals. Okay? Notice how I applied the integral that dx respect to both, and I constant multiple rolled out both of the coefficients. Alright, x to the negative 1/2 becomes x to the what? When I add 1 to the power, what is x to the negative 1/2? X to the 1/2. Multiplied with what? Multiplied with 2 over 1, right? Okay, because you're going to divide by the new power. Reverse power rule, you're always going to divide by that new power. And then we're going to multiply this negative 2n right here as a coefficient. Okay? What is the integral of dx? X. So we're going to multiply this constant multiple rule of 4. We know the antiderivative of x is x, and it's going to be plus c. Okay? So all of this that we just got right here, you could write here. I just knew that I was going to run out of room. That's why I didn't write it there. Okay? So, all this highlighted in gray right now. What does it represent? Which function does it represent? The position. It represents f of x. So if I were to, again, just like this analogy here with this example problem from Algebra 1, if I set it equal to f of x, I can then use this point that they gave me from the position and put in 0 for my x values. And I'm going to put this 0 here for my output y value. So you have the input and the output. Anyone, from what you see, what would c equal? C would equal 0. Okay? Because c is equal to 0, I can take this general solution here and make it more particular and just plug in 0. So my final answer would be negative 4 square root of x plus 4x. There's no plus c because that c became 0. Any questions? Alright.